Spectacles may seem simple, but they are actually a product of mathematical precision, design and engineering that improve vision and comfort while enhancing style. Let's explore the role of math in spectacles. Frame shapes and sizes, even mismatched frames, such as one lens in a circular frame and the other in a square frame, involve symmetry and proportion. While asymmetric designs may appear playful, they still use mathematical principles to maintain balance, comfort, and correct alignment on the face. The lenses in spectacles are precisely shaped based on geometric principles to correct refractive errors. Calculations involving radius, diameter, and curvature allow for accurate light refraction, ensuring that the wearer's vision is focused correctly. The optical center of each lens needs to be perfectly aligned with the wearer's pupils to prevent strain. Using measurements of the interpupillary distance, PD, opticians calculate and adjust the lens placement within the frames to optimize vision and comfort. Geometric curvature enables precise light refraction in lenses, tailored to individual prescriptions. Lens materials vary in refractive index, which determines the thickness of the lens. Thinner, high-index lenses require precise calculations to maintain the correct prescription strength without adding weight, while polycarbonate or glass lenses are chosen for durability and clarity. Therefore, from lens crafting to frame design, mathematics is woven into the creation of spectacles, enhancing both function and style while meeting the unique needs of each wearer.